All right, the trapezoidal prism question. So this is actually number 65 here. It says, what is the surface area of the figure? So before we can do anything, we have to know what kind of shape it is. And it does have 4 rectangular sides. Therefore, it's a prism. And the bases are trapezoids. So I'm going to kind of sketch that out for you. Here's the base. Important to understand that I kind of dot this one. That just because this thing is on its side, see it's laying on its side, that doesn't mean that this is the base. A lot of students will think, oh, the bottom's the base. No, no, no. The base is the most unique side. Usually the sides that are not rectangles. In this situation, the bases are trapezoids. So it's a trapezoidal prism. So for that, we need the formula, the surface area formula for a prism, and it looks like this. Okay. And what do all these things mean? Let's talk about that real quick. P here, capital P stands for the perimeter of the base. H here stands for the height of the prism, and we'll talk about what that means in a second. And then capital B here means the area of the base. And so as we find all this information, we just plug it in and we'll have our answer. So let's first deal with the perimeter. And the perimeter of the base is this distance that I've already highlighted for you. It's this distance all the way around the base. Now the problem here is they only give me this top and bottom distance. I don't have these side lengths. But they do give me this little 60 degrees. So let's play with it. What if I was to draw a line straight down here? And this will be incredibly helpful because that would turn this into a 30, 60, 90 triangle. And if this distance above is 8, then this distance below must be 8. And then this distance must be 4. Now, here's the part where you need to know your properties of 30, 60, 90s. 30, 60, 90s. This is the short leg. And so to find the long leg, all I do is take the short leg and multiply it by the square root of 3. So this distance must be 4 square root 3. And since this is a rectangle over to the right, this must also be 4 square root 3. Now, for the hypotenuse, you take the short leg to get the hypotenuse, you double it. So this must be 8. And now I've found all the parts that I need to find the perimeter of this shape. So I'm going to go ahead and go over here to my formula. And I'm going to color code it here. So the perimeter would be 8 plus 8 plus 12. So 28 plus 4 rad 3. So I'm just going to leave it in exact terms for now. So 28 plus 4 rad 3. Okay, there's the perimeter. But now I need the height. And remember we said earlier that this prism was on its side, making this really the base and this really the base. So that means this distance here is the height. That is the height. So when I go to plug it in, 13 is my height. Okay, so now we're moving on to the base area. So let's just keep filling in our equation here. Plus 2 times, and now we got to do the area of the base. I'm going to do this one in green. So the area of the base, well, in order to calculate this, we need to know what kind of shape the base is. And we already said that the area of the base is a trapezoid. So the area for a trapezoid is 1/2 height, little base 1 plus little base 2. All right, so this is important as we go to plug all this stuff in. This is the height of the trapezoid, and these bases are the 2 parallel sides. So the 8 and the 12 are parallel, so those are your base 1, your base 2. So let's go ahead and plug all that in. It'd be times 1/2 times the height. Well, the height is also this distance of 4 rad 3. So 4 rad 3 times base 1 and base 2, like I said before, the bases are the parallel parts, so that's just 8 plus 12. Okay, I've now found all the parts I need to find the surface area. Remember, that's what I'm trying to do, is the surface area for this thing. Now, the next part from here is if you have a calculator, really, you could just plug all this into the calculator. But what I want to show you from here is how you could actually calculate this in exact terms without a calculator at all. So let's go through it. One of the first things that I see, so the first thing I see here is this 13 times 28 and 13 times 4. Now, you may actually need a calculator to do 13 times 28. But it's possible to do it without a calculator, because you could do 10 times 28, which is 280, and 3 times 28, which is 84. So 84 and 280 is 364. Now, you could use a calculator to do that, and that's fine. And 4 times 13, well, let's see, 10 times 4 is 40, 3 times 4 is 12, so that's going to be 52. So that would be 52 square root 3. Now, over here, again, the whole point here is I'm just showing you how you can get an exact answer. 2 times a half. Well, those things just kind of cancel each other out, right? Like 2 and a half, that's just 1. So we don't even have to think about that. And then 8 plus 12, well, that's just 20. So I have 4 rad 3 times 20. And 4 times 20 is obviously 80. So I have 80 square root 3. And over here I still have 364 plus 52 rad 3. Well, see, these are like terms here, right? Because they're both square root 3. So 80 plus 52 is 132. And so this is what we would call an exact answer. And now we would want to also put that this is units squared, because we're talking about area here. But in advanced mathematics, it's going to be helpful to be able to get exact answers. We like exact answers in higher math. But for the sake of this problem in your class, you could literally just plug all this into the calculator and get an answer with a decimal in it, and you'd be good to go. Okay, see you guys on the next video.